Good morning. Today we are talking running biomechanics. I find running biomechanics incredibly interesting. If there were two of me, all right, I spend what the current version of me spends a lot of time understanding lifting performance and its relation to how it can influence sports performance. The other version of me would purely study biomechanics with a lot of that related to running biomechanics. It's incredibly interesting stuff where, researchers and sports scientists and coaches are just continuously discovering new ways to both improve performance and reduce running related injuries. Just a quick example off the top of my head is Google the Nike Vapor Flies and all of the drama, controversy surrounding the Nike Vapor Flies right now. The Nike Vapor Flies are this like carbon fiber shoe, which essentially allows runners to be incredibly more economical, which thus in turn allows them to run faster. When Eliud Kipchoge, he broke the 2-hour marathon barrier about a year ago. He did it in the Nike Vaporflies. And what you're starting to see in running is a lot of runners are starting to utilize these Nike Vaporflies to actually run faster. The big question is like, are they actually better? Are they improving human performance? Or is it really science of technology that's kind of enhancing human performance? And that's a different debate. But again, that's just a quick example of how biomechanics can impact sports. So we can't talk biomechanics without at least having a very brief overview of how Newton's laws of motion affect or how they relate to biomechanics. So we've got 3 laws, all of which you guys should have some familiarity with. The law of inertia, the law of momentum or acceleration, and I forget the name of the third law. These slides formatted incorrectly. So the law of inertia, an object will stay at rest unless acted upon by an external force. An object in motion will stay in motion unless acted upon by an external force. So as we are sitting, right, we will not move or we won't go to run until we are acted on by an external force like our bodies. We won't be, for falling from a free space, right, we will continue to fall unless acted upon by an external force that stops us. I would say Newton's second law is particularly important with regards to running, and it's the law of momentum and acceleration. So the simple formula is force equals mass times acceleration, right? And then I have this quote, right? And it says acceleration of an object experiences proportional to the resultant force. So it's based on the force and is inversely proportional to the mass, right? So the force you apply will result in a specific amount of acceleration. That's another way to think of it. And inversely proportional to the mass. So what do we try to do as coaches, right? We try to increase our ability of our athletes to increase force production, right? That's always our goal, because if you can put out more force, you can accelerate quicker, right? The other alternative, and this is often used in distance runners, is by decreasing your body mass. By decreasing your body mass, you can increase your ability to accelerate. So that's by losing weight. Now, obviously, especially losing weight is a fine line for distance runners. A perfect example that comes to mind is Mary Kane, a distance runner who at a very young age went out to be a professional at the age of like 16 or 17. She went to a professional group with Alberto Salazar, and one of their ways to get their runners to be fast was to lose more weight. Well, without a proper nutritionist and a proper approach, she started to lose weight, we'll say incorrectly. Not her fault whatsoever, more so a fault of the coaching camp. And inevitably, she started to experience what we would call the female triad. Her bones started to atrophy. It's not the right word, but her bones lost some density, and she started to experience fractures, right? Bone fractures. This kind of, to an extent, ruined her professional running career. So this Newton's second law has to be applied correctly when working with distance runners. And Newton's third law, for every action, there's an equal and opposite reaction. So as we push into the wall is pushing back. As we jump up from the floor, the ground is pushing back from us. And these really, what this really is ground reaction forces, which we now can measure with force plates. So just a quick overview of biomechanics, right? So biomechanics is the study of movement and limb positioning in relation to forces, right? So biomechanics can really be viewed from two different perspectives. We can look at kinematic data or kinetic data. Kinematic data is really studying the movement itself, the movement patterns, the movement positions. So an example of that would be, we've got various running phases, which I'll get to in a little bit, but I said maybe at the end of the terminal swing phase, when we're starting to initiate contact, how many degrees of knee flexion do we have? So that's describing the movement itself. Conversely, kinetic data really starts to look at the forces of these positions. So it's the forces of these kinematic positions, the forces of this kinematic data, right? So kinetic data really studies forces. So what happens at the end of that terminal phase when you're initiating foot contact? Well, maybe you're generating 1,000 newtons of force, 1,500 newtons of force. That's how we measure force. We measure it in newtons. So here is a visual of the running gait cycle phases. The top picture shows you what it actually looks like. So remember, we're looking at the right leg for this. So at the right leg of this runner, we see initial contact. We go from initial contact to mid stance to takeoff. Then we go through the right leg is going through initial swing phase, mid swing phase in the fifth picture, and then finally the terminal swing phase where we are about to experience contact, initial contact. So this is what I was describing kinematically, right, in the last slide. This terminal swing phase, how many degrees of knee flexion do we have about in this picture? With a straight leg being 0 degrees of knee flexion, I don't know, maybe they're going through 30, 35, and this is going to vary based on the shoe type, based on the runner. Beginning runners and advanced runners have very different foot contact patterns, which can really influence both your speed, your economy, and your injury resilience, I'll say. At the bottom is kind of just another model of the running phase. So it's showing you like what your absorption and your propulsion phases are, right? So if we're looking at initial contact, from initial contact to takeoff, right? We're at initial contact, what are we doing? We're absorbing forces, and then as we move through our mid stance phase, we start to move into a propulsion phase. All right, so this is just a visual of what a running pattern looks like. What you guys, if you're looking at the top picture, what you'll have to know for your lab at the end is what are we looking at in terms of foot strike pattern, right? So we're talking about what hits the ground first. So if you see the top picture, what looks like it's going to hit the ground first? I don't know, maybe his heel. Definitely does not look like his forefoot, the front of his foot's going to touch the ground first. Either his heel or maybe his midfoot. We're also looking for when the foot hits the ground, where is it in relation to our center of mass? Our center of mass being somewhere around the hips, give or take. In this picture, right, let's just say he's touching the ground. He's clearly, his foot is way out in front of his center of mass. So that's a few things you guys are going to have to look for in terms of your lab. So what I provided for you guys is a study done by Pearl et al., which looked at both rear foot striking and forefoot striking, and it looked at maximalism versus minimalism in runners, which I'll get to in a little bit. So just a quick background on running. They proposed that there's really been two major changes in running. over the last, whatever it is, 50, 100,000 years. And one would be just the invention of shoes or moccasins, right? And that really occurred about 50,000 years ago. But they proposed that the biggest change was these modern shoes, these modern running shoes, which really took place in about the 1970s and 1980s. Why did this change take place? Well, probably because there was a major increase in the popularity, it says popularity of running in the 1970s and 1980s. So despite us trying to make running better, make running easier, reduce the injuries, right? There's actually been an increase in running related injuries, even though we know all sorts of new information. You know, in the 1950s, 60s, and 70s, we didn't really have that much information. But despite this, we're actually getting worse with regards to running related injuries. And the big question is why? Some people seem to think that they have an answer to this question. And that comes down to what we would call maximalism versus minimalism in the running community. Generally speaking, a maximalist is something like a conventional running shoe, with the extreme end being something like orthotics, right? So what is this? Well, this is any conventional running shoe that really supports the foot, right? So it's got a large thickened heel. It's got a large amount of arch support and a stiffened midsole. These guys can also be known as shod runners going forward. The belief was that by having all these kind of support systems in place, these support systems would actually absorb some of the impact, thus reducing some of the injuries. However, we've seen that that's not the case because from the 1970s and 80s, injury rates in runners have only gotten worse despite these shoes. So probably in around the early 2000s, we started to see a shift in some people within this community, which we've termed minimalists. And this is little to no foot support. Odds are that many of you have probably seen a minimalist, in that it's usually the extreme end of a minimalist would be obviously no shoe. The next version of a minimalist would actually be somebody that wears Vibram fingers, right? They're not quite as popular right now, but I would say like 6, 7, 8 years ago, Vibram fingers were incredibly popular in a lot of communities. And their theory or rationale was essentially that we naturally evolved to be barefoot runners, right? You know, whether it was 50,000 years ago or 100,000 years ago, you know, we had these like moccasins, or we just didn't run with anything, and we were still running out in surfaces. You know, taken to a more extreme level, there's some other rationales which I'll get to, but you know, essentially, minimalists believe that when you have this like massively supportive shoe, your muscles within your foot aren't really doing anything. So what do? They atrophy, versus a minimalist whose foot muscles have to do a lot more and inevitably just become much stronger. Right? So what we found is that the vast majority of runners are what we would call a rear foot striker. So now we're talking about the kinematics, right? We've seen the vast majority of runners actually touch the ground with their heel first. And this usually is this is a chicken or the egg kind of situation. Well, usually this will add to a longer stride pattern. And if it's a longer stride pattern, this may actually negatively affect running performance. Now, what we found in a lot of the literature, like we know this pretty clearly, is that a forefoot striker, so if you land on your toes, you tend to be more economical than a rear foot striker. How do they measure this? They measure this through gas exchange. So an example would be using a metabolic cart, right? We can determine how much energy we're expending, right? We've talked about this in the past before, right? So the question would be, which group does what? Maximalists tend to be a rear foot striker. Minimalists tend to be a forefoot striker. The structures of the shoes, both the weight and the positioning of them, with the thickened heel of a maximalist shoe, forces the shod runners to be much more of a heel striker, a rear foot striker. The structure of a minimalist shoe usually forces minimalists to be much more of a forefoot striker. And we've measured this being much more economical than rear foot striking. So the question is, like we've seen it now. The question is why? Why is forefoot striking possibly superior to rear foot striking? Well, the theory is that the tendons and muscles and ligaments within both our feet and our legs, as we run, they start to experience recoil. And we do know this. You guys should know this from 45-20, the stretch shortening cycle. Just because we're not doing a plyometric jump doesn't mean we're not experiencing some sort of deformation, right, in our Achilles, in our foot muscles, okay? So what happens, and these pictures on the right sort of illustrate this, is that we want to take advantage of our Achilles tendon, right, and its elasticity. What we found, if you utilize your Achilles tendon, it recovers approximately 35% of the elastic energy and is transferred right back into running. But if you run with much more of a heel foot strike, what happens is the Achilles tendon is not stretched nearly as much. And then, since it's not stretched nearly as much, a lot of that energy is lost. It's not transferred right back into running. And then running just simply costs more on your musculature that has to kind of get you up to speed or make you run faster. The second point here is the arch is positioned to experience a more of a stretch in a forefoot strike. So if you look at these pictures on the right, both A and B, A is much more of a forefoot strike. So we land right here at this point, right, on the A picture on the left, and then because of this, our arch experiences a larger stretch. And once it experiences more stretch, it experiences more recoil, and very similar to the Achilles tendon, much of that is transferred into running. If you look at picture B, we're landing already on this kind of this right circle here, and because of this, like the best muscle or tendon to talk about is the plantar fascia. The plantar fascia is not stretched. If it's not stretched, you can't experience recoil and you can't experience this return to kind of running energy. Okay. Another explanation is that the knee tends to be in a more optimal position. With a heel foot strike, well, let's talk about a forefoot strike. At a forefoot strike, we found research that shows that the knee is more quote unquote compliant at its landing position. It's in a slightly more bent position, so it's more compliant to absorb impact. Usually in a rear foot strike, the knee, because we have that longer stride, the knee is a little bit more extended and is less compliant, which negatively affects that running pattern. So stride frequency. This isn't really illustrated in the pictures. We've found, and if you read the Pearl article, that we have this rough idea of what an optimal stride rate is. What I'm not going to do is I'm not going to tell you guys, because you guys have to do this in lab. I want you to either read the article or do your lab and count your steps. I mean, you're going to have to do that anyway, and figure out if you're in roughly the right range for a stride frequency, or for what we think is an optimal stride frequency. What we do know is that shod runners tend to have a lower stride frequency than barefoot or minimalist runners. So what were the major findings of this specific study? Of this specific study, where they took, I think it was 15 runners, and they put them through 4 different trials, both minimalism, maximalism, both heel foot and forefoot striking, we found first, right, with just simply the lighter shoes, right, it's going to save you 1% per 100 grams of shoe. So we said that a maximalist shoe is approximately 350 grams, while a minimalist shoe might be about 100 to 150 grams, depending on where you're getting your information. That's a pretty big difference. At the very least, it's going to make you approximately 2% more economical, just from a weight perspective, because the minimalist shoes are lighter, right? But in addition to that, Pearl et al. Found that minimalist shoes were approximately 2.4% less costly than traditional shod runners. So, I just did some math here, and it says, so a 3% increase in running economy, right? So this is saving you energy, right? You're utilizing less energy. That's what running economy is. This could increase running speed by about 0.147 meters per second. I did this about 2 years ago, I think now, and I did the math. A 3% increase in running economy, when equated out, it could equate to 9 to 10 minutes in a marathon, which is crazy. 9 to 10 minutes. 10 minutes in a marathon could have you, I don't know, going from first place in the Olympics to not even qualifying. If you run a 2:05 marathon, you're in contention to be an Olympic champion. But if you run a 2:15 marathon, you won't even get to the Olympics, right? So just by being in a minimalist shoe and being a forefoot striker, we're experiencing somewhere between a 3, 4, 5% increase in running economy. And this 3% increase in running economy can have profound impacts on running speed. Again, there are inherent individual variability. There's inherent variability based on the individual, right? There's certain people that might only see a 1% increase, but this is what we found generally to be true on average. So when you guys are putting together your individual running programs, you guys want to at least do some things that are going to affect some of these variables, right? So stride rate, we've loosely talked about. Contact time, how much foot contact time is there with the ground? Foot strike, we've definitely talked about that. Rear foot, midfoot, forefoot strike. Vertical bouncing, when we're running, we don't want to have too much vertical displacement because it costs energy to kind of to move upward, right? Hamstring pulling action, appropriate arm action, right? What we're going to do with our lab is you guys are going to address both stride rate, foot strike, and not necessarily. So we're going to look at stride rate and foot strike within your lab. So for your lab, what you have to do is you have to download some sort of video analysis software. 2 quick, easy ones are Dartfish or OnForm. I have both of them. Both of them should be free up to a certain amount of videos. Do not pay for a video analysis software, right? Do not pay for a video analysis software. From there, what I would like you to do is record running videos. Right, you have to record several. I want a front and a side view. So I want a video of you like this, and then a profile, right, like that, of you actually running. All right, and it should be approximately 5 to 10 seconds. And I want a video of you for both angles at a steady state, something that you can run for, I don't know, 15 minutes if need be, and then at a relatively fast pace. So not an all-out sprint, but something relatively fast. Make sure for the lab you warm up on your own before you do anything, and then you could start recording these videos. What I want you to record in terms of data, right? This should be within your lab. I want to see whether you determined that you are a forefoot striker, a midfoot striker, or a rear foot striker, and do it on each foot, because it does happen where sometimes runners may be more of a midfoot striker on their left foot and then a forefoot striker on their right foot. That can happen. Also, like if you've ever had any significant injuries, I can see extreme differences. So if you've had a significant injury, you might be a forefoot striker on your left and maybe a rear foot striker on your right. So that depends. I want to know your stride rate for both the steady state and the fast pace. How many steps per minute are you doing this? How do you calculate stride rate? Very simple. When you're running at both paces, I want you to have a watch, whether it's your phone or watch, and I want you to calculate 1 foot, right? How many ground contacts does it have? So as you're running, how many times does your right foot hit the floor in 30 seconds? Multiply that number by 2, right? It could be 20, could be 30, could be 50, could be 60. How many ground contacts for 1 foot? Multiply that number by 2, and that will get you your stride rate for one leg. You multiply that number by 2 and you'll get it for 2 legs. Again, I'm not going to give you guys exact guidelines. It is in the Pearl paper what an optimal stride rate is. But again, I want to know what your honest stride rate is. So is it 100 steps per minute, 150, 200, 250? Some of those numbers might not be realistic. And then the last thing I want you to record is your foot placement. So at initial contact, where is your foot in relation to your center of mass? Is your foot out in front of you? Is your foot at initial contact a little out in front of you, directly underneath you, behind you, so on and so forth? Okay, so I want to see at initial contact. You don't have to do this stuff for every single step. I just want to know for the right foot, for the left foot. Is the foot under the center of mass or out in front? For the left foot, for the right foot. Are you a forefoot striker or a rear foot striker? And this should be done at each speed, steady state and fast. Okay. So on the right is your guidelines for the write-up. I want an introduction, 4 points, addressing why running biomechanics matters, and always a purpose statement. What's the purpose of this lab? Results. I need a table of all of the data that I've requested, and it should be a table. A discussion. Explain your results. Explain what happened, and then provide a mechanistic explanation for the results. So why do you think you are a forefoot striker or a heel foot striker? Why do you think this affects your running related paces, so on and so forth? Have you been injured from running? Could some of this stuff maybe explain some injuries from running? All right. I want you to include a minimum of 2 peer-reviewed articles as references. I'm going to allow you, if you want, to use this Pearl article as one. So you're going to have to go out and find another. That's not too bad. That'll be worth 2 points. And then finally, keep it in APA format. The lab in total will be worth 20 Edpuzzle points. Okay. How long should this lab be? Same thing as the last one, not too long. You know, something in the neighborhood of a minimum of 3, probably 4 to 5 pages, something like that. How much time should you spend on this? Not a tremendous amount, because you guys have a lot of other work. And I think that's about it. If you guys have any questions, let me know.